welcome back. Today we're going to talk about reference angle. Reference angle is going to allow us to find the exact values for trig ratios using angles that we already know in the coordinate plane. The positive acute angle, theta hat, that is formed by the terminal side and the x-axis. That is the reference angle. And so reference angle really is only talking about the angle that's formed with the x-axis. And so each of these values is going to be in reference to, that's why it's called reference angle, the x-axis. So it's all of these values here. Notice, it's not all the way around, it's only in terms of where it lies with the x-axis. And so when we name reference angles in example 1, we are going to put them in standard position. Each of these is going to take a coordinate plane. And so I'm going to draw those out. And I'm going to show you exactly what this looks like. And you're going to see that this is going to help us immensely in finding those exact values. Let's look at 30 degrees, knowing of course that we always start with the positive x-axis. We're going to open it up like this. And so our reference angle, theta hat, is 30 degrees. And so this can be written theta hat equals 30 degrees because that's the positive x-axis. That's what it's in reference to. It's easy when the reference angle is in the first quadrant. Well, when we get over to the second quadrant, we know that this is going to be 90, and then this is going to be a 45-degree angle over here. Well, really, theta hat is this part here, because it's in reference to the x-axis. And so our reference angle here is 45 because that's the angle that's formed with the x-axis. Okay? It's kind of a difficult concept to understand at first because we are used to saying, well, how far does it go total? Really, all we care about is where it is in reference to the x-axis. 240, so I'm going to go 90, 180, and another 60, right? And so that's my theta hat because it's in reference to the x-axis. So my theta hat for this one is equal to 60 degrees. See if you can do the last one by yourself. It's in reference to the x-axis. This one goes 90, 180, and another 60 would be 240 total, but the reference angle is 60 in reference to that x-axis. So here's an in general. If theta is in quadrant 1, then theta hat is equal to theta, just like up here. It was in quadrant 1, so the theta hat is the same. What about if it's in quadrant 2? Well, if I look at 135, theta hat is equal to 180 minus theta. So 180 minus 135 would give me that 145. If theta is in quadrant 3, we are going to have theta hat equals theta minus 180. Okay, so 240 minus 180 would give me 60. And if theta is in quadrant 4, theta hat is going to be equal to 360 minus theta. Okay? Example 2. So now we're going to use this to find the exact values of these things. Well, when I'm finding exact values, really what I'm asking you to do is find the theta hat, label the triangle. So once again, I'm just going to use my coordinate planes here. And I'm going to use those known triangles that I know. Sine of 240. Well, first let's put in this angle. So I've got 90, 180. And so this triangle here is going to be my reference triangle. And I know that this is going to be 60. So theta hat equals 60 because that's going to be 90, 180, 60. And so this is 30. And so I know when I label this triangle, this is going to be 1 because it's the short side, opposite of 30. 1, and then so the longer side is going to be 1 times square root of 3, and this one's going to be 2. Remember when we put those in there using those special right triangles? And so what's going to happen is the sine is the opposite of the hypotenuse or that y over r. And so that's going to be equal to, now, the y is that square root of 3, and the r is 2. Well, I know that this is negative because it's in this third quadrant here. So it's going to be negative square root of 3 over 2. That's my exact value. Notice, no decimals involved. Let's look at this next one. If I've got 315, 90, 180, 270, so 270 and another 45 here. So that means this is 45 here because this is 90. And so this is 1, negative 1, square root of 2. Special right triangles, remember? So the tangent is equal to opposite over adjacent. And so this is my angle here that I'm looking at. Opposite over adjacent is going to be negative 1 over 1. So that's equal to negative 1. It's all about putting these special right triangles to work, because this theta hat is equal to 45. And that's this right here. That's what it is in reference to that x-axis. So that's the gist. Let me help you with this last one. I'll have you finish it, but I'm going to help you out. I want to put in the reference triangle first. And so it's going to go 90, 180, 270. And so when I put this in, I know this has to be another 30, so that means this is going to be 60 here. Okay, so this is 30. And so when you put in your values, you know that the side opposite of 30 is the shortest, so we'll just call that 1. And the side opposite 60 is square root of 3. And that's going to be negative style because it's in the fourth quadrant. And then this one's got to be 2. So when you find cosecant, remember that's 1 over sine, right? So that's that. Coterminal angles. Coterminal angles are these beautiful, beautiful repetitions of a pattern that give us the same answer. And so they differ from each other by multiples of 360. So if I say that this is 0 and I go all the way around, it's also 360. Well, guess what? I can keep going all the way around again. It's also equal to 720. It's also equal to 1080, okay, etc., etc. So those coterminal angles go all the way around. Well, if I've got 495, look at what happens. If I start out at 0, I get back to 360, okay? And then if it's 360 also, if I go another 90, that's 450. So if I get to here, this is going to be 450. And so if I go another 45, that's 495. Well, notice what happens. This is a 45-degree angle here. So my reference angle is one of those regular ones that's like this. This is 1. This is negative 1. This is 2. So my reference triangle is all the way around 360, 450, 495. And so this is my reference triangle. And so my theta hat is really equal to 45 degrees. And so it doesn't really matter what that angle is because coterminal angles keep going and going and going. And so my cosine of 495 is equal to, this is actually 135, it's actually equal to the cosine of 135 because they are coterminal angles. And that's equal to adjacent over hypotenuse, or x over r, which is equal to negative 1 over 2. Okay? You see how that works? That's a beautiful thing right there. That's the first part of reference angle. So make sure, if you draw out those reference triangles, you can find theta hat really easily, and it'll give you a nice way to find those exact values for the trig ratios. Thanks for watching, guys. We'll see you next time.